tax and finance, investments. Where R is the annual interest rate, the annual compounding or multiplicative factor can be expressed as I equals 1 plus R%. Now, let's take an example of what that means. For example, if someone is giving an interest rate of 8%, this is equivalent to a compounding factor of I equals 1 plus 8%, or 108%, or 1.08. So in other words, if you invest an amount of money at 8%, you get 100% of your money back, plus 8% for the interest. So it's 108 in total, or 1.08 times your original investment. Example 1, a fixed rate fund. Calculate the value of an investment of €100 after 4 years if it's invested at the rate of 8% for the entire duration. So there are a number of numbers here. 4 years tells us the duration of the investment. So we can draw that by considering time now, the end of year 1, year 2, year 3 and year 4. And there are 4 cycles involved for each of the 4 years, 4 investment periods of 1 year each. This is time moving from left to right. The €100 is invested now at the beginning. So it's on the left hand side, showing that this is where we start. And the 8%, which equates with the compounding factor of 1.08, is what's going to happen to this €100 on an ongoing basis. It's going to be multiplied by this multiplicative factor 1.08. So now we just do the sums. The €100 multiplied by 1.08 becomes 108. Again, in the second year, by 1.08 times 108 becomes 116.64 cents. And in the third year, it grows to 125.97. And when multiplied again by 1.08, gives us a total of 136.05. An alternative approach is to use a formula where you say the principal invested was €100 times 1.08, the multiplicative factor for each of the 4 years. So 1.08 to the 4 by 100 is €136.05, as we achieved up here. Example 2, changing rate fund. Calculate the value of an investment of €1,500 after 6 years, where the interest rate for the first 2 years is 5% and for the remaining years is 6%. So a bit more complicated. Here the period of investment is 6 years, so we can imagine now the end of year 1, year 2, all the way to the end of year 6, or 6 individual years of investments, all having an impact on the fund. €1,500 is the amount of money invested, and it's invested at the start, so we can show it at the beginning here. We're also getting 5% and 6% interest. So the 5% applies to the first 2 years and the 6% the remaining 4 years. Now we can do the calculations. 1,500 by 1.05 gives us 1,575. Multiplied by 1.05 again in the second year, the fund grows to 1,653.75. For each of the next 4 years, we're multiplying by 1.06. So 1,653.75 by 1.06 grows the fund to 1,752.98. And in each year it continues to grow until in the end of year 6, it's €2,087.82. Alternatively, we could have used the formula €1,500 initially, 2 years of a multiplicative factor of 1.05 for the 5%, followed by 4 years of the 6% or 1.06 multiplicative factor, giving us a total of €2,087.82. Example 3, a retirement fund. Siobhan wishes to retire in 4 years' time with a lump sum payment of €100,000. How much would she have to invest now at 4% to meet this requirement? Well, 4 years are involved, so we've got now year 1, year 2, year 3 and year 4. But we want a payment of €100,000 at the end of year 4. So in a way we've got to look back now in time and to say how much do we need to put in now to make this. And we need to put in less than 100,000 because it's going to grow. So if we're working back, instead of the multiplicative factor being 4% or 1.04, we can be dividing by 1.04. Because if we were here, moving forward, we'd multiply. If we're at the end, moving back, we can divide. So dividing now, 100,000 divided by 1.04 reduces the amount to 96,153. In effect, if we had 96,153.85 cents at the end of year 3 and invested it for the year, we'd end up with 100,000. So working back, it gets smaller. Divide again by 1.04, we're down to 92,455.62. Divide again and divide again, so that after 4 years, we need now to invest €85,480.42 to have 100,000 in 4 years' time. The method you would use here would be to take the principal that you want, and given that it's in the end, in the future, you now divide by the multiplicative factor 4 times. So 100,000 not multiplied, but divide by 1.04 to the 4 gives us €85,480.42. An alternative method would be to look forward and to say, I don't know how much I need, so I'm going to assume I'm going to put in X euro, investing that now and see how it grows. If I put it in for 4 years, it will grow at 4% or a multiplicative factor of 1.04 to the 4. I want that X by 1.04 to the 4 to be 100,000. 1.04 to the 4 on a calculator is 1.169858. X times that is 100,000. And if I divide by this number on both sides, I get X is 100,000 divided by 1.169858 or €85,480.42 as before. Here's an example where there are annual payments involved. Cert wishes to retire in 3 years' time with a retirement fund of 100,000. To do so, she intends to make 3 equal payments into an investment fund at the start of each of the 3 years. If the fund yield is 7% per annum, how much is her annual payment into the fund? So there's quite a lot going on here. First thing we note that it's in 3 years' time, that she wants to have a retirement fund of 100,000, but unlike the previous question, we're talking here that she's willing to make these investments of equal payments at the start of each of the 3 years. So each of the 3. And the fund is 7%, so our multiplicative factor will be 1.07. So drawing the question, we can see we've got a 3-year cycle, a 3-year window to make up the retirement fund. We want that fund at the end to be 100,000. But we're willing to put in not just one investment of X, but 3 investments at the start. One now, the end of year 1, the start of year 2, and the start of year 3. None at the end. Each of those investments is going to grow by the multiplicative factor 1.07. So the first investment of X will grow by X by 1.07 or 1.07X. But note that we're also making a second investment of X, so at that stage we'll have 2.07X involved. All of the 2.07X is going to be compounded or by the multiplicative factor 1.07 in the next year. So we'll get 2.07x times 1.07, or 2.2149x. Yet again, we're going to make another investment of x. So that x will add to the 2.2149x, giving us 3.2149x. All of that money will be invested for the last year at 1.07, giving us 3.2149x times 1.07, or 3.439943x. Now, we're no longer making another investment of x, so the total amount we have 3.439943x, or 3.439943 times the investment we're making annually for each of the 3 years. And we wish that to be 100,000. So the total value, 3.439943x, must equal 100,000. And if we divide both sides by this number, we get x equals €29,070.25. The alternative approach for this question with the annual payments would be to take the annual payment x and multiply it by the multiplicative factor for 3 years in the case of the first investment, 2 years in the case of the second, and 1 year in the case of the third, and make that equal to 100,000, or 3.439943x, 100,000. X is the same value as before, €29,070.25. Claude invested €1,000 in a fund for 5 years. In the first and the fifth year, the interest rate was 5%. During the intervening years, the money was in a fixed rate account. What was the fixed rate if the total at the end of the 5 years was 1388.88 So let's look at some of the numbers. Claude invested €1,000, 5 years, and in the first and the fifth year, the interest rate was known, 5%. Or a compounding factor of 1.05. During the intervening years, the money was in a fixed rate account and we don't know what that rate was. What was the fixed rate if the total at the end of the 5 years was 1388.88? Now, where we don't know a number, we use x. So let x be the compounding rate for the years 2, 3 and 4. So we can visualize the question. We've got 5 years in total, starting now to the end of year 5. We know initially we had €1,000 and that it grows to 1388.88. We know that the interest rate for the first year was 5%, so a compounding of 1.05, and similarly the same in the last year. But for the 3 intervening years, we're using x as our multiplicative factor because we don't know what that multiplicative factor was. Moving forward, we could say the €1,000 at 5% would grow to 1,050, the 5% plus the original 1,000. Another, multiplying it by x, we don't know what the factor is, so we're using x. 1,050 times x is 1,050x. Multiplying by x again, 1050x squared, and by x again, 1050x cubed. Now we could multiply that again by 1.05 to equate it here, or we could work back. Working back, we can see that if we have 1388.88 at the end of year 5, and we had 5% interest for that year, we can divide by 1.05 to know that we had €1,322.74 at the end of year 4. And that must equal 1050x cubed. So we can do the equation here, or we could have carried it forward to there. So solving for x, 1050x cubed is 1322.74, or dividing both sides by 1050, we get x cubed is 1.259755. The alternative method here will be to take the principal of 1,000, multiply by the 1 year you had 5%, the 3 years for which you don't know the compounding factor, and the other year for 5%, and equate it to the amount you had at the end. So you had Multiplying in, we 1102.5x cubed is 1388 and 88 cent, or x cubed is, as before, 1.259755. But we're not interested in x cubed, we're interested in the compounding factor per year. So to solve for an x cubed, to get rid of the cube, we take the cubic root of both sides. So the cubic root of x cubed will result in us getting x, but if we do it on the left hand side, we do it on the right. So the cubic root of x cubed is the cubic root of 1.259755. That gives us x is equal to, with the calculator, 1.259755, hit function cubic root, and we get 1.08001, or approximately 1.08. So now, to find the interest rate, the compounding factor I is 1 plus the interest rate, or 1.08. So if 1 plus r% is 1.08, 1 plus r% is 1.08, we can take the 1 to the other side. R% is 1.08 minus 1, or 0.08. R% is r over 100. R over 100 is 0.08. Multiplying both sides by 100, we get r is equal to 0.8 by 100 is 8. R% is 8%. So effectively, the interest rate for the fixed period for that was 8% for the intervening years 2, 3 and 4.